Hello again, welcome to another lesson in geometry. Today we are covering section 11-6, surface areas and volumes of spheres. All right, so we have some vocabulary review here. Underline the correct word to complete each sentence. Number one, the radius of the circle at the right is 5. This only goes halfway across the circle. Okay. Number two, the circumference of the circle is the product of the diameter and pi, or it can be 2 times pi times the radius, because remember 2 radius is the same length as a diameter. Number 3, the diameter of a circle is a segment containing the center with the endpoints on the circle. Okay, so our segment needs to have the center in it and the endpoints are on the circle. So that green segment contains the center. All right, a sphere. This is a sphere here, just a ball. Okay. Related words are spherical. That's the adjective that explains something as being ball shaped. Or hemisphere, which is half of a sphere. So think of a ball cut in half. Okay. A sphere is formed by the revolution of a circle about its diameter. So if you took a circle and you just spun it around and around the diameter, you get a sphere. Okay. A sphere is a set of all points in the space that are equidistant from a given point called the center. So an example would be a basketball is a sphere, and a non-example would be a football, because that is not spherical. Okay, it's pointy on the ends. All right, complete each statement with sphere or spherical. So each blank candy looks like a rock. So this would be spherical. So each spherical candy looks like a rock. Okay. A baseball is in the shape of a sphere. All right, right, true or false? Celestial bodies such as the sun and earth are often represented as spheres. This is true. Most celestial bodies are sphere-like. They're not perfect spheres. Okay, a sphere is a two-dimensional figure. This is false. It's a three-dimensional figure. Remember, we are taking a circle and we're drawing in one of its diameters, and then we're going to spin that circle around and around until we get a 3D object. So all of the points that are equidistant from this spot. And when we're done, we're going to get something that looks like that. Okay, on the top of page 2, we have theorem 11-10, surface area of a sphere. So the surface area of a sphere is 4 times the product of pi and the square of the radius of the sphere. So this is going to be 4 times pi times the radius squared. So the only thing we need to know for a sphere is just what is its radius. Okay. All right, problem number 1. Find the surface area of a sphere. What is the surface area of a sphere with a diameter of 14 inches? Give your answer in terms of pi and then round it to the nearest square inch. So what is the radius of the sphere? So if it's a diameter of 14, then the radius is going to be half that, so that would be 7 inches. And then find the surface area of the sphere. So use the formula here. So this was 4 times pi times r squared. And then we're going to substitute 7 in for the radius. And then 7 squared is 49, and 49 times 4 will make 196. So this is our exact answer in terms of pi. And then we can use our calculator and type it in. It's going to turn into about 615.752 and keep on going. So we're down here. The surface area of the sphere in terms of pi is 196 pi, which is about, to the nearest square inch, 616 inches squared. All right, problem number 2, still about finding the surface area of a sphere. What is the surface area of a melon with a circumference of 18 inches? Round your answer to the nearest 10 square inches. Okay. All right, so complete the problem-solving model below. So the circumference is 18 inches. What do we need? Well, we need to know the radius, because that's the important part to do formulas for a sphere. And then we, of course, need to know the surface area of the sphere after we find the radius. So our plan is to solve the formula for the circumference for the radius, to figure out what that is, and then substitute the radius into the formula for the surface area of the sphere. All right, so let's see. We know our circumference is 18 inches. So we'll let C be 18. And then we have 2 times pi times r. So to get r by itself, we're just going to divide both sides by 2 pi. So we're going to get r equals 18 over 2 pi. We're just going to leave it just like that for now. Or you could reduce it if you felt like it. 9 over pi. Either way is fine, because in the end, we're not going to use that number in our answer. Okay, so now we're going to go over here to get our surface area, because we know what the radius is. So the surface area is going to be 4 times pi, and in place of r, we're going to put 9 over pi, or you could put 18 over 2 pi in there, squared. Okay, and then we're going to simplify. Okay, so the pi's are going to cancel. Oh, no, they're not. Let's see, we're going to get 4 pi, and then that's going to be times 81 over pi squared. All right, so on top, we're going to do 4 times 81. Okay, and on the bottom, we're going to cancel out the pi to get pi squared. But we aren't asked to get this as an exact answer. We're asked to just get this to the nearest 10 square inches. So we can just type on our calculator at this point, and we're going to get about 103.13, so forth. And that's going to round to 100. Okay, this 3 is not going to make that 0 get 1 bigger. So the rounding to the nearest 10 square inches is actually rounding to that second spot to the left of the decimal. Okay, so we're going to end up with 100 inches squared for the surface area of the melon. All right, let's flip it over. Okay, on the top of page 3, we have theorem 11-11, the volume of a sphere. Okay, so once again, the only thing we need to know is the radius to get the volume of the sphere. And the volume of the sphere is equal to 4/3 of the product of pi and the cube of the radius. So we're going to write it like this, 4/3 the product of pi and the radius cubed. Okay. Draw a line from each measure in column A to the corresponding formula in column B. So we just learned volume of a sphere. That's the 4/3 pi r cubed. And then the surface area of a sphere is 4 pi r squared. Now, next time in class, I'll show you some videos about how they came up with these. All right, problem number 3, finding the volume of a sphere. So a sphere has a diameter of 60 inches. What is the volume to the nearest cubic inch? So complete the missing information in the diagram. So the volume formula is 4/3 pi r cubed, and the diameter is 60 inches, so the radius is going to be 30 inches. All right, so we plug in 30 in here, and then it says complete and find the volume. So 4/3 pi, and then we're going to say this will be 30 now in place of r, so 30 cubed. 30 cubed is 27,000. 3 times 3 times 3 is 27, and then 10 times 10 times 10 will give you 3 extra zeros. And then we have to multiply that by 4/3, which will give us 36,000. So this is our exact answer, 36,000 pi. And then if we type that on the calculator, we're going to get about 113,097.3355, go on forever. Okay, so the volume is about 113,097 inches cubed. All right, problem number 4, using volume to find the surface area. So we're going to use both of our formulas this time. So the volume of a sphere is 42,000 feet cubed, or I'm sorry, 4,200 feet cubed. What is the surface area to the nearest tenth? So circle the correct formula to find the volume of a sphere. So that's going to be 4/3 pi r cubed. I always remember this formula by the volume answer is going to be in cubic meters or cubic inches or cubic units. So that's how I know to use the formula with a cube. And the surface area is going to be in inches squared or meters squared or units squared. So that's why I use a formula with a squared in it. Except unfortunately, this is not the surface area formula. All right. Complete the following reasoning model to help us here. So you need to solve for the volume formula for the radius. So we know the volume, we would like to get the radius. So it said in our problem, the volume is 4,200. So we're going to put 4,200 where the V is. And now we're going to solve for R cubed. So we'll times both sides by 3/4 and then divide both sides by pi. And we're going to end up with 4,200 and times by 3/4 and then also divided by pi. So we'll put the pi on the bottom of the fraction equals R cubed. Okay. And now to get rid of the cube on the R, we're going to have to do the cube root. You can draw the cube root just like you do the square root. We just put a cube symbol in it. So in here we're going to type 4,200 3/4 pi. And then we're going to use our calculator to simplify. And I'll show you how to do a cubic root on your calculator in class next time. So this is going to give us a radius that's about 10.0089, so forth. Okay. All right, now we can substitute R into the formula for the surface area of the sphere. So we're going to do 4 pi times 10.0089, so forth. You're going to want to store that value in your calculator so that you can carry it down to do your surface area with it. Okay, and when you're done here, you're going to get 1258.878 something or another. Okay, so to the nearest tenth of a foot, the square area, surface area is going to be 1258.9 feet squared. Okay, so remember the surface area formula is pi times 4 times the radius squared, and our volume formula is 4/3 times pi times the radius cubed. So we're using both of those formulas. Okay, so for our lesson check today, we're going to do a little bit different. It has a new vocabulary word in it, so you can't really pause the video and try it yourself. So our vocabulary is, what is the ratio of the area of a great circle, so we haven't talked about, to the surface area of the sphere? So a great circle is a circle whose center is the center of the sphere. So if you had a sphere, here's the center right here. So we want one of the circles that goes with the center is the center of the sphere. So we could just use this circle here if we want it. Okay. So we want to know the area of this circle compared to the surface area of the sphere. So the area of that circle is going to be pi r squared. Okay. The surface area is going to be 4 pi r squared. Okay. Same r in both cases because it's still just the radius of the sphere, because the radius of the sphere is the radius of the great circle. So the ratio of the area of the great circle, so we want the great circle on top compared to the surface area of the sphere, so we want the surface area on the bottom. So what's going to happen here when I do some canceling? The r squareds are going to cancel each other, the pi's are going to cancel each other, and we're going to get left with 1/4. Okay. All right, so that completes the lesson for today. Check off the vocabulary words that you understand. So hopefully you have sphere down, radius, diameter, circumference. Those are all words we've used before. Great circle is a new one. Remember, that's just the largest circle that you could draw to a sphere, or a circle is the outside of the sphere combined with the center point of the sphere. And then a hemisphere, remember, is a sphere that's been cut in half right through one of the great circles. Okay. Rate how well you can find the surface area and volume of a sphere. So these are 2 new formulas we learned today, but I'm pretty sure you can use them pretty well. If you're not in here, though, you should definitely go back and watch this video again, and then I'll see you in class next time to practice some.